Hello. So let us do the example, the question 1a here. Observation that here is a power series, right? Therefore, there are two tests we may be able to use here. First, the root test, or what else? The ratio test. Okay, that is what we observed. So now we're given that an like this, int. So an here is given by this definition. Therefore, an plus 1 will be all the terms here, but n will be replaced by n plus 1. And here, radical sign of n plus 1 and then plus 1. Since let us write it here is negative 3 to the n times 3 times x to the n times x here. Radical of n plus 2. Therefore, we're looking for the limit when n goes to infinity of an plus 1 over an here. N goes to infinity. Since we do it many times, we know that at the end, the ratio of these two things, an plus 1 and an, will be this guy, an here, right? Multiplied with a reciprocal of an, which is square root of n plus 1 divided by negative 3 to the n times x to the n. Okay, now look at this. Both numerator and denominator has this term, so they cancel each other. Same case here, negative 3 to the n, and here we have negative 3 to the n, right? It means that the limit becomes the limit when n goes to infinity, and the number 3, we just write it here, x, right, in the numerator. And in the numerator, there is a term of square root of n plus 1. In the denominator, we can definitely write the whole things here, multiply with square root of n plus 2, right? But we can also write it as 3x times square root of n plus 1 divided by square root of n plus 2, because these are all product. And the power rule tells us that n plus 1, first n plus 1 and n plus 2 are both positive. And they have the same power, right? Which is 1/2, or they are all under the square root things here. And here, number 3 times x, we can write it as this guy, because we know that the square root of this is positive, But now we can also write n plus 1 over n plus 2. They have the same power. We can write it in the same radical sign right here. So 3 is a positive number. We can take it out of the absolute sign here. And here, this guy, in order to observe it better, let us write this guy. If we divide both numerator and denominator by n, we have that it will be 1 plus 1 over n. The denominator becomes 1 plus 2 over n here. Then n goes to infinity. This guy becomes 0. This guy becomes 0. Or in other words, the square root of this becomes square root of 1. So in the end, the limit of this guy becomes 3 square root of x. This is the ratio test, right? Okay. So the ratio test, the theorems say that if the result, which mean 3x, 3 absolute value of x in this case, if, so we consider case study right here, case 1, if 3 times absolute value of x is strictly smaller than 1, then the power series, or simply say series in this case, is absolutely convergent, right? So we see that 3 absolute value of x smaller than 1, it means that when we divide both sides by 3, we have that absolute value of x smaller than 1/3 here. From definition, the absolute value of x smaller than a number, we call this number the radius of convergence, right? R is equal to 1/3. Remember, absolute value of x is smaller than 1/3. It means that x is larger than negative 1/3 and x is smaller than 1/3. Definition of absolute things. You can go back, review it, definition of absolute value of x. Or in the real line, you can visualize it here. Absolute value of x is the distance from the x to 0. Suppose in this case, suppose x is any point between negative 1/3 to 1/3, we see that the distance from the point x to 0 here is definitely smaller than 1/3, right? Makes sense. That is the graphical meaning of absolute values. Anyway, now the first case when x between here, then it is absolutely convergent. We can easily conclude the second case immediately right here. If the absolute value of x larger than 1, or we can observe the this one when we do some algebra, we can observe it easily when x will be smaller than -1/3, right? Or the other case when x is larger than 1/3. Okay? Or we can write it in set notation. X between -infinity to -1/3 union with 1/3 and infinity. We conclude that the series is divergent. That is the second case, right? The third case, when the limit of the ratio test is equal to 1, we don't know. It is inconclusive, or in other words, x will be at -1/3 or 1/3 right here. We have to write it explicitly and use different tests to have a conclusion about this series. At x is equal to -1/3, then the series becomes, what is it? The series from n is equal to 1 to infinity of -3 to the n here times x, which is 1/3 to the n divided by square root of n minus 1, right? Yes, correct. So, or now -3 to the n, we can definitely write it as -1 times 3, right? To the n. And 1/3 to the n, we can also write it as 1 to the n divided by 3 to the n, right? They are the same things. The denominator, just rewrite it, n minus 1. We write it here this way so that we can observe it better. For those who don't remember power rules now, you can see it's not very difficult. The product of two things raised to the n will be each of them raised to the n, which mean we have that -1 to the n times 3 to the n here. Then times here, 1 to the n is simply 1, right? Divided by 3 to the n, and they are all now divided by square root of n minus 1. You see that 3 to the n times 1 over 3 to the n will be simply 1, right? They cancel each other. Or in other words, the series here becomes -1 to the n times 1 divided by the denominator here, n minus 1. N is equal to 1 to infinity. Is it convergent or divergent? And how can we test it? Have any suggestion, Andy?
Would that be like the alternating series?
Yes, you're right. It is an alternating series, right? Because we have the negative 1 to the n. Very good. So how can we test if an alternative series is convergent?
We could take what is it called? It's like 8. No, that's limit comparison test. I know we had to like I'm not sure.
Alternative series test, right? Alternating series test. It means that we have to check two conditions. First, that is the limit of this guy, right? Equal to 0. We need to check these things. Second, we have to check that if we call this guy Bn, okay, let us call one over square root of n minus 1 here, then what we need to do is that we need to check if limit of Bn here is equal to 0. The second thing is, what is it? That the sequence Bn here should be decreasing, or we say that Bn plus 1 smaller or equal to Bn for any n is equal to 1, 2, 3, etc. Or in other words, we can write n is integer here. Okay, so let's do it. It is clear that the limit 1 over n minus 1 square root here, when n becomes, this guy, sorry, my bad. From definition, it is positive, right? First one, my bad. This should be positive plus 1 here. When n becomes very large, this denominator will become large, 1 divided by a very large number. Therefore, it is the limit here is 0. Makes sense. The second condition, right? N plus 1, Bn plus 1, and Bn. What is Bn plus 1?
It'll be 1 over square root of n plus 1 plus 1.
Yes, which is 1 over square root of n plus 2, right? And Bn here is 1 over square root of n plus 1, right? We need to prove this. And it is easy to see that n plus 1 is smaller then n plus 2, or any n in the integer set, right? So we take square root of both sides, the inequality is still whole. Then when we flip it, then the inequality should change the sign. This is a basic rule of inequality, right? So we see that when we've done this, the two conditions of the alternating series test are satisfied. So therefore, the series
It's converging, right?
yes, convergent. By the alternating series test. Okay. Is that clear?
Yes, it's very clear.
Okay, very good. Then that is the first point at negative 1/3, right? We have to do the similar things at x is equal to 1/3. Okay. So the case 4 here, at x is equal to 1/3, the series becomes, we do the same algebra here, right? But in this case, oh, my bad. In this case is when I plug in the value is x is equal to 1/3. My bad. Yeah. Anyway. Okay. You see the mistake here? Actually, when I plug in here, I just plug in 1/3. Therefore, let us change here. Now, at x is equal to negative 1/3 here. This guy is, we substitute the value of x is negative 1/3. Then this guy, it will be, what is it? Negative 1, negative 3
So,
to the n, right?
okay, yeah. Negative 1/3.
Yeah. Or anyways, this guy will cancel each other. And in the numerator simply becomes what?
1.
Very good. 1 over here. Right. This series, what is it?
Divergence.
Why?
Because 1 over square root of n plus 1 is. I know you use the divergence test, right?
No.
No?
The divergence test, when you use it when the limit of the sequence is converged to a number which is not 0. In this case, the limit when n goes to infinity, this 1 over this guy, it converges to 0. So the divergence test is not working here. But we can see that this sequence here, this series, is similar to another series. Do you know which one?
No.
What is it?
It would be 1 over n.
Mm, close, but not that, not 1 over n. One over square root of n. Why? Because the highest order of this guy is n to the 1/2, right? Or square root of n. So that is why we consider this sequence here, this series here. This series, is it convergent or divergent?
It would be divergent
Why?
because it's similar to 1 over square root of n plus 1. So it would be n goes to infinity, right?
No, I mean, I'm asking the red series here.
Oh, okay. 1 over square root of n is divergent because P
It is
series.
a p series, right?
Okay.
Where p in this case is 1/2, which is smaller than 1. So this series is divergent.
Because you make the square root of n into n over 1/2.
Very good. Yes, that is. Right. Okay. This series is divergent. Okay. However, moreover, the limit. We consider these two guys, this guy and this guy. Okay. The limit of these two, when n goes to infinity, 1 over square root of n plus 1, and divided by this sequence, which is divided by 1 over square root of n, or it is the same as
Square
1.
root of n over 1.
Yes. And here, the same story, right? It is square root of n divided by square root of n plus 1. Okay. Same things. We can write they are all in the same radical sign, n divided by n plus 1. Okay. What should we do to find the limit of this guy?
Divide by n.
Very good. Because the highest order of these two are n. So when we divide both numerator and denominator by n, we have that the numerator becomes n by n, which is 1, right? What is
It's 1.
1 and what?
Oh, we 1 in plus 1.
The whole denominator divided by n. N plus 1 divided by n. Let us do a psi computation. This is a fraction, right?
So 1 plus 1 over n.
Very good. That's it, right? When n goes to infinity, this guy becomes the limit of square root of 1, or this guy becomes 0, or simply the limit will become square root of 1 or 1. Okay, so therefore, the series 1 over n plus 1 here, and the series n is equal to 1 over square root of n are both convergent or divergent. By which theorem? By the limit comparison test, right? Okay, the limit is equal to a constant, then they are both convergent or divergent together. Furthermore, we have just proven here this guy is a p-series and it is divergent. Okay, therefore we conclude that this series is also divergent, right? Okay, these are the all situation of the value of x. So let us summarize it here. The first case when x is between negative one third, it is convergent. Outside of that, it will be divergent. At 1/3, it is convergent, right? And at negative 1/3, it is divergent. So, summary. The radius convergence is r is equal to 1/3, and the intervals of convergence, right? Is x between at negative 1/3, it is divergent, and at 1/3, it is convergent. Okay, and the series is divergent. On the interval. Negative infinity, negative 1/3 here, and 1/3 to infinity. That's it.